Good morning, students. Yesterday we introduced vector product, that is cross product, and we learn to learn vector product, that is cross product. We need the following formulas. Yesterday we completed 5 formulas. They are definition of cross product. A vector cross B vector equal to modulus A vector into modulus B vector into sin theta into n cap. Next, working rule to find A vector cross B vector. That is, let A vector equal to A1i plus A2j plus A3k. B vector equal to B1i plus B2j plus B3k. Then, A vector cross B vector is equal to determinant ijk. First column always fixed, determinant ijk. Now, here first A vector, therefore A vector components comes in second row. Second B vector components in third row. That is, A vector cross B vector equal to determinant ijk A1, A2, A3, B1, B2, B3, which is second formula. Next, third formula, parallel. If A vector and B vector are parallel, then angle between them, theta is equal to 0 degree. Then by the definition of cross product, A vector cross B vector is equal to modulus A vector into modulus B vector into sin 0 into n cap. We know that sin 0 is 0. Therefore, right side fully 0. That is, if the two vectors are parallel, then A vector cross B vector is equal to 0 vector. That is, if A vector cross B vector equal to 0 vector, if and only if A vector and B vector are parallel. So, which is third formula. Now, fourth formula, cross product of itself vectors. For example, A vector cross A vector is equal to. Now, every time we are see definition of cross product. A vector cross A vector equal to definition, please. Yes, is equal to modulus A vector into modulus A vector into what is angle between A vector and A vector? Yes, 0 degree. That is sin 0 into n cap. Sin 0, 0 again equal to 0. That is, A vector cross A vector equal to 0 vector. Similarly, B vector cross B vector equal to 0 vector. C vector cross C vector is equal to 0 vector. For example, X vector cross X vector is equal to 0 vector. What is the concept? Yes, the cross product of itself vectors equal to 0 vector. Okay. Next, angle between two vectors A vector and B vector using cross product or using vector product. Otherwise, find the angle between A vector and B vector using sign formula. So, the question may be asked in 3 ways. That is, find the angle between A vector and B vector using cross product, using vector product, otherwise using sign formula. Whatever may be the topic, the formula is sin theta is equal to modulus A vector cross B vector divided by modulus A vector into modulus B vector. What is the technique? Yes, sin theta equal to total modulus by separate modulus. Okay, until to this, yesterday we completed. Now, formula 6th one. Listen, 6th one is the unit vectors perpendicular to both A vector and B vector is given by the formula n cap. And we are going to find n cap. How to derive the perpendicular unit vector to both A vector and B vector is given by the formula n cap. And from the definition of cross product, we can derive the formula. Now listen, 6th one is very simple. First definition, A vector cross B vector is equal to. Can you tell me what is the definition of cross product? Yes, A vector cross B vector is equal to modulus A vector into modulus B vector. Listen, first one, modulus A vector into modulus B vector into, yes, sin theta into n cap. Okay. Let it be the first equation, which is first equation. Okay. Now, taking modulus on both sides, taking modulus on both sides. Okay, here up to yourself. Taking modulus on both sides, what happened? Yes, left hand side, total modulus. That is, modulus A vector cross B vector is equal to modulus A vector cross B vector equal to modulus A vector, already modulus available itself. Already modulus B vector, already modulus. So, modulus B vector. And modulus sin theta equal to sin theta, because sin theta is a scalar, so itself into sin theta into here n cap, so that is why modulus n cap. Okay, can you tell me what is modulus n cap? Yes, which tends to 1? Because n cap is the unit vector to both a vector and b vector. So that is why modulus n cap tends to 1. Okay, 1 into anything? The same. That is modulus a vector cross b vector is equal to modulus a vector into modulus b vector into sin theta. Let it be second equation. Okay, now our topic is the perpendicular unit vector to both a vector and the perpendicular unit vector to both a vector and b vector is given by the formula n cap equal to something. So I want to derive n cap equal to. So for my convenience, first equation divided by second equation. That is now 1 by 2. That's 1 by 2. Listen, 1 by 2. 1 by 2 becomes. Okay, 1 by 2 becomes. See, right hand side divided by right hand side is equal to left hand side by left hand side. Okay, which means what is the right hand side? Right hand side first equation is modulus a vector into modulus b vector into sin theta into n cap. Okay, divided by second equation. Second equation modulus a vector into modulus b vector into sin theta. Okay, which is equal to RHS divided by RHS is completed, which is equal to LHS divided by LHS. What is LHS? Yes, LHS is given by a vector cross b vector divided by, here LHS is modulus a vector cross b vector. So modulus a vector cross b vector. Okay. Now any simplification? Good, very good. Modulus a vector cancel next. Yes. Modulus b vector cancel next. Very good. Sin theta cancel. What is remaining? Yes, n cap. So n cap is equal to a vector cross b vector divided by modulus a vector cross b vector. Okay, now come to the topic. The unit vectors perpendicular to both a vector and b vector is given by the formula n cap is equal to a vector cross b vector divided by modulus a vector cross b vector is a formula. But this n cap is perpendicular unit vector. Perpendicular unit vector means, listen, it is the unit vector is a screw typed vector. Suppose from downwards, okay. See, listen, it is a screw typed vector. Screw it, yes, it comes upward. So which is plus n cap. Suppose, why not? So the screw maybe comes top to bottom. Okay, listen, yes, it comes downward. So it comes downward means minus n cap and it goes top plus n cap. So the formula is plus or minus n cap. So plus or minus n cap is equal to plus or minus n cap is equal to plus or minus a vector cross b vector divided by modulus a vector cross b vector. So the unit vector goes upward, that is it is a screw typed vector, goes upward plus n cap and goes downwards which is minus n cap. So plus or minus n cap. Now let us write question with answer. Now listen, the unit vectors, listen, it is very important. The unit vectors. The unit vectors perpendicular to both a vector and b vector. Perpendicular to both a vector and b vector is given by the formula. The unit vectors perpendicular to both a vector and b vector is given by the formula plus or minus n cap. Okay, which is equal to plus or minus n cap is equal to plus or minus n cap equal to plus or minus a cross b divided by modulus a cross b. Okay, which is equal to plus or minus long divide and for my convenience put a moon bracket for numerator. That is moon bracket a vector cross b vector divided by modulus a vector cross b vector. That's all. So again, the unit vectors perpendicular to both a vector and b vector is given by the formula plus or minus n cap is equal to plus or minus a cross b divided by modulus a cross b. Okay, see how to learn this formula? Yes, listen, here no modulus by total modulus. A cross b, the same. A cross b, what is the difference? No modulus by total modulus. Here numerator no modulus, but the denominator is total modulus. So no modulus by total modulus is given by the formula plus or minus n cap. That is a perpendicular unit vector to both a vector and b vector. Okay, what is the difference between sin theta formula? That is angle between two vectors using cross product. Yesterday we learned that is sin theta. Listen, Sin theta is equal to, anyone? Yes, sin theta is equal to modulus A vector cross B vector divided by modulus A vector into modulus B vector. See, it is a sign formula to find the angle using sign formula. Otherwise, find the angle using cross product or find the angle using vector product. Vector product or cross product, both the same. Okay, what is the difference between these two formulas? How to learn easily? Yes, here listen, sin theta equal to total modulus by separate modulus. But plus or minus n cap is equal to plus or minus no modulus by total modulus. So it is a technique to learn easily. Okay, again, sin theta equal to total modulus by separate modulus. But plus or minus n cap equal to plus or minus no modulus by total modulus. So that is the difference. Okay. Now, here it is a perpendicular unit vector to both A vector and B vector. And the unit vector means its magnitude, modulus n cap is equal to 1. Here magnitude is 1. Here n cap coefficient 1. So that is magnitude 1. Here right answer also its coefficient is 1. Suppose the vectors of magnitude lambda, it is here the magnitude is 1. But suppose magnitude is 2. Sometimes magnitude is 3, magnitude 6 or some magnitude lambda, some magnitude mu likewise. Now let us frame a new formula. The vectors of magnitude lambda, perpendicular to both A vector and B vector is given by the formula plus or minus lambda into n cap equal to plus or minus lambda into A vector cross B vector divided by modulus A vector cross B vector. Okay, similarly, can you tell me the vectors of magnitude 6 perpendicular to both A vector and B vector is given by the formula? Anyone? Yes, very good. That is, which is equal to plus or minus 6 into n cap equal to plus or minus 6 into A vector cross B vector divided by modulus A vector cross B vector. Okay. Next question. Anyone you want to say? Listen. The vectors of magnitude mu perpendicular to both A vector and B vector is given by the formula. Anyone? Very good. That is plus or minus mu into n cap is equal to plus or minus mu into A vector cross B vector divided by modulus A vector cross B vector. Suppose magnitude lambda means lambda. Magnitude mu means mu. Suppose magnitude 6. Suppose magnitude 5, yes 5. Suppose magnitude 10 root 3, yes 10 root 3, here 10 root 3. So that is a technique. Let us write one more formula for our convenience. The vectors of magnitude lambda, the vectors of magnitude lambda. The vectors of magnitude lambda, okay? The vectors of magnitude lambda perpendicular to both A vector and B vector, perpendicular to both A vector and B vector. A vector and B vector is given by the formula. Okay, yourself? Yes, simply plus or minus lambda into n cap, that's all. Listen, plus or minus lambda into n cap is equal to, anyone? Yes, plus or minus lambda into A vector cross B vector divided by modulus A vector cross B vector, that's all. Okay, similarly, suppose the vectors of magnitude 6 perpendicular to both A vector and B vector is given by plus or minus 6 into n cap equal to 6 into, that is plus or minus 6 into A vector cross B vector divided by modulus A vector cross B vector. Okay. Children listen. Now seventh formula. Okay. Seventh one. Dot product is commutative. That is A vector dot B vector equal to, yes, B vector dot A vector. That is dot product is commutative. A vector dot B vector is equal to B vector dot A vector. But vector product is non-commutative. Okay, vector product is non-commutative. Vector product is non-commutative. vector product. Vector product is non-commutative. Dot product is commutative. A vector dot B vector equal to B vector dot A vector. But vector product is non-commutative, which means what? A vector cross B vector is not equal to B vector cross A vector. Listen, A vector cross B vector is equal to is not equal to B vector cross A vector. Non-commutative. A vector cross B vector is not equal to B vector cross A vector. But in before exercise, dot product is commutative. That is, A vector dot B vector equal to B vector dot A vector. X vector dot Y vector equal to Y vector dot X vector. B vector dot C vector is equal to C vector dot B vector. Dot is commutative. But here, in vector product, that is in cross product is non-commutative. Vector product is non-commutative. But, listen, A cross B not equal to B cross A. But A cross B is equal to minus B cross A. But A cross B is equal to minus B cross A. One can write. Okay. Listen. A cross B not equal to B cross A, but A cross B is equal to minus B cross A. So in cross product, if the vectors are interchanged, gets negative sign. See, for example, B vector cross C vector equal to, yes, minus C vector cross B vector. Okay, likewise. So which is vector, seventh one is completed. Now listen, suppose eighth one. So eighth one, let us consider the three-dimensional. In three dimension, x-axis, y-axis, z-axis, origin 0. Along x-axis, the unit vector is, yes, good, I cap. Along y-axis, the unit vector is, yes, j cap. Along z-axis, the unit vector is, yes, k cap. Okay, listen, I cap, comma j cap, comma k cap are the perpendicular unit vectors, or the mutually perpendicular unit vectors in right-handed system. That is, I to j and j to k and k to I. Okay, that is right-handed system. Okay, now listen, for my convenience, so can you tell me what is I cap cross I cap? Anyone? Yes, I cap cross I cap. I cap cross I cap. Now definition of cross product. Can you tell me what is the definition of cross product? Yes, from the definition of cross product, here first one I cap. So modulus I cap into second one also I. Therefore modulus I cap into sin theta. Okay, what is theta? Yes, angle between I vector and I vector is very good, 0 degree. Therefore sin 0. Okay, into n cap. N cap means here I vector, so this n cap itself. Okay, the perpendicular vector to I vector is considered as n cap. Now we know that sin 0, 0. Okay, which sin 0, 0. 0 into right side fully 0. So therefore I cap cross I cap equal to 0 vector. Because vector product gives vector answer. That is cross product gives vector answer. Okay, I cap cross I cap equal to 0 vector. Similarly, j cap cross j cap equal to 0 vector. K cap cross k cap equal to 0 vector. So therefore, see, I cap cross I cap is equal to j cap cross j cap is equal to k cap cross k cap equal to 0 vector. So what is a concept? Yes, the cross product of itself unit vectors equal to 0. Not only unit vectors, but also yesterday we completed A vector cross A vector equal to 0 vector. B vector cross B vector equal to 0 vector. That is cross product of itself vectors is equal to 0 vector. Okay. Next, suppose I cap cross j cap. Okay, which is equal to. Okay, by the definition of cross product, yes, first one I vector, therefore modulus I cap. Second one j vector, that is j cap, modulus j cap into sin theta. Okay, what is theta? Very good, 90 degree, because angle between I cap and j cap, listen, angle between I cap and j cap is equal to 90 degree, because I cap, j cap, k cap are mutually perpendicular unit vectors. Mutually perpendicular unit vector. So that is 90 degrees, sine 90 into here the perpendicular unit vector to both I cap and j cap. Listen, the perpendicular unit vector to both I cap and j cap is given by k cap. So inside of n cap, here coming k cap, that's all. Okay, now modulus I cap tends to 1, very good. Next, modulus j cap tends to 1. Next, sine 90, yes, very good, sine 91. Now listen, 1 into 1 into 1, 1. So 1 into k cap, that is k cap. So I cap cross j cap is equal to k cap is the answer. Okay, and the initial also, here also, sine 0, 0, and the modulus I cap tends to 1, modulus I cap tends to 1. So 0 into 1 into 1, 0 into anything 0, so that is a 0 vector. Okay, now listen the technique. Here ij present, absent will be the answer. Okay, that is the technique. Ij present, so absent k is answer. Now, in cross product, if the two vectors are interchanged, what happens from commutative? Yes, vector product is non-commutative, but A cross B equal to minus B cross A. Likewise, I cross J is equal to minus J cross I. Suppose, what is J cross I? Anyone? I cross J equal to K cap. Now, my question is, J cap cross I cap equal to? Yes, minus K cap. Minus K cap. Because that is, since listen, that is, I cap cross J cap is equal to minus J cap cross I cap. So that is why. Here, I cross J equal to plus K means J cross I is equal to minus K because A cross B equal to minus B cross A. Similarly, I cross J is equal to minus J cross I. So which is a technique. Okay. Now, similarly, see, I to J is completed. Suppose now my question is J to K. That means, can you tell me what is a J cross K? Okay, J cross K. And I have one more idea. Here I cross J. That means I to J. Here Ij present absent K. So K will be the answer. Here Ij present absent is K. So okay, now my question is when plus, when minus. So that is the problem. Now in the vectors, that is I to J. I to J means I to J right-handed system, therefore plus K. And J to I, that means, listen, J to I is a left-handed system, therefore minus K cap. So right-handed system gives positive answer and this left-handed system gives negative answer. That's the idea. Now can you tell me what is here? JK present. So JK present, I absent, therefore I will be the answer. Okay. Now my question is whether plus I cap or minus I cap. So that is a problem. For that, come to the diagram, J to K. Listen, J to K. J to K right-handed system, therefore plus I. Okay. Suppose K cross J, which is equal to, yes, here JK present, so absent I will be the answer, whether plus or minus. So that is my problem. Now, here whether plus or minus means here K to J, listen, which is K to J. K to J is left-handed system, so that is why minus. That is why minus. Okay. Now listen, first one, I to J completed. Now J to K completed. Now cyclic order, that is I to J completed first one. Next J to K completed second one. Now K to I, that is now K cap cross I cap, which is equal to here I K present. So what will be the answer? Yes, absent is J. Absent is J. Whether plus J or minus J. So that is my question. Okay, for that K to I, come to the question from the diagram. K to I, right-handed system. K to I, right-handed system, therefore plus. Suppose I cap cross K cap, which is equal to I K, absent J. Okay. Now plus J or minus J. Here I to K, listen, come to the diagram. I to K, left-handed system. So that is why minus. That is why minus. Okay. Now these results we can put into the table. Listen. First here cross product. Okay, it is cross product, and there are three unit vectors: I cap, j cap, and k cap. Here also I cap, j cap, k cap. Okay, now complete the table. First horizontal lines, then vertical lines. Okay, vertical lines. Now what is the product? Fill it here. Yes, I cap cross I cap equal to, yes, 0 vector, because cross product of itself vectors equal to 0 vector. A cross A equal to 0 vector. I cap cross I cap equal to 0 vector. Similarly, fill it here. Yes, j cap cross j cap equal to 0 vector. Here, k cap cross k cap equal to 0 vector. Okay. Now, here what is your answer? I cap cross j cap. That is alphabetic order. Listen carefully. I, j, k. Okay. See, I to j. I cap cross j cap. That is I to j, right in the system. Here I to j means k opposite, whether plus k or minus k. I to j, right in the system. Okay. I cross k. I cross k. Okay, listen. I cross k. I cross k means, listen, I cross k, left-handed system. So I cross k, left-handed system. So that is why ik means j will be the answer, but a negative. Okay, similarly, come to here. J cross I. J cross I. See here, j cross I means k will be the answer, no doubt. Option is k, but a plus k or minus k, that is question. Here, j to I. Listen, j to I, left-handed system. So that is why minus. Okay, here, j to k. Okay, j cross k, j to k. Here, jk means I will be the answer, no doubt, whether plus or minus. Here, j to k. J to k means, yes, j to k, positive. That is right in the system, that is why plus. Over. Come to here. Yes, k cap cross I cap. K, I. So option is j, whether plus or minus. So that is my question. Here, k to I. Listen, come to the diagram. K to I. That is k to I right in the system, that is why plus. Here next, k cap cross j cap. Here kj, option will be I. I will be the answer, whether positive or negative, that is my question. Here k to j. K to j means, listen, yes, k to j, it is left-handed system, so that is why minus. K to j is minus. So this table is completed. Children listen, so up to 8 formulas completed. Now listen, ninth one. Ninth one is, consider the parallelogram. Yes, consider the parallelogram. Here, area of the parallelogram, listen carefully. Area of the parallelogram with adjacent sides A vector and B vector is given by the formula. Okay? Listen. Area of the parallelogram with adjacent sides A vector and B vector is given by the formula modulus A vector cross B vector. Okay? Listen. Area of the parallelogram. Area of the parallelogram. Area of the parallelogram. Okay, area of the parallelogram with adjacent sides A vector and B vector is given by the formula. With adjacent sides. With adjacent sides. With adjacent sides A vector and B vector is given by the formula. Okay, area of the parallelogram with adjacent sides A vector and B vector is given by the formula modulus A vector cross B vector. Okay, modulus A vector cross B vector, that's all. Area of the parallelogram with adjacent sides A vector and B vector is given by the formula modulus A vector cross B vector. That is, area of the parallelogram is nothing but cross product of adjacent sides. Cross product of adjacent sides. Area of the parallelogram is given by cross product of adjacent sides with a modulus, that's all. Suppose, listen. Let ABCD be a parallelogram. Suppose. Let ABCD be a parallelogram. Now here consider, here AB vector and AD vector are adjacent sides. So the same formula one can rewrite. That is, area of the parallelogram with adjacent sides AB vector and AD vector is given by the formula modulus AB vector cross AD vector. Listen carefully. Area of the parallelogram with adjacent sides AB vector and AD vector is equal to modulus AB vector cross AD vector. Okay? It is enough. And now listen, 10th one. 10th one is here parallelogram contains two equal triangles. Listen, here area of the triangle, listen carefully, area of the triangle ABC is equal to area of the triangle ACD. So a parallelogram contains two equal triangles. So area of the triangle ABC equal to area of the triangle ACD. That means area of the triangle ABC equal to half into modulus A cross B. That's all. So area of the triangle means half of the area of the parallelogram. Half of the area of the parallelogram. Now listen the concept. For my convenience, let us draw the diagram. Suppose. Listen, the diagram is here. I think no place to write here. So I will continue here. Okay, sir. Listen, 10th one. Listen the diagram. Here, let A vector and B vector, let A vector and B vector be the adjacent sides of the triangle. Let A vector and B vector be the adjacent sides of the triangle. Then, area of the triangle with adjacent sides A vector and B vector is equal to half into modulus A cross B. That's all. So, area of the triangle. Area of the triangle. Okay, area of the triangle. Area of the triangle with adjacent sides A vector and B vector. With adjacent sides. With adjacent sides A vector and B vector is given by the formula. Area of the triangle with adjacent sides A vector and B vector is given by the formula half into the same, that is half of the area of the parallelogram, half into modulus A cross B. So half into modulus A vector cross B vector. Half into modulus A vector cross B vector. That's all. So which is 10th one. Suppose listen, for example, let ABC be a triangle. See, for example, let ABC be a triangle. Here, AB vector and AC vector are the adjacent sides. AB vector and AC vector are the adjacent sides. So we can frame the formula ourselves. Area of the triangle ABC is equal to half into AB vector cross AC vector. Area of the triangle ABC equal to half into AB vector cross AC vector. Suppose, let us change the diagram. Let PQR be the triangle. Here PQ vector and PR vector are the adjacent sides. Area of the triangle PQR is equal to half into PQ vector cross PR vector. So this formula is not fixed one. According to the adjacent sides, the formula going to change. Here, area of the triangle with adjacent sides A vector and B vector is equal to half into A vector cross B vector. Here, area of the triangle with adjacent sides AB vector and AC vector is equal to half into AB vector cross AC vector. Area of the triangle PQR with adjacent sides PQ vector and PR vector is equal to half into PQ vector cross PR vector. That is, every time modulus important. Okay, that's all. So area of the triangle is nothing but half into modulus of cross product of adjacent sides. That's all. Okay, this diagram only. So 10 formulas completed. So to learn 8.4 exercise, it is enough to learn these 10 formulas thoroughly. Children listen. Example 20. Find modulus A cross B where A vector and B vector is given. Okay. So to find this answer, first complete this inside portion, which is A vector cross B vector is equal to. Listen, if the cross product is defined between the two vectors, when the components are given, that is ijk. A vector and B vector is given by the components of ijk, then determinant, that is, if the cross product is defined between the two vectors, which is equal to determinant IJK. Determinant IJK. When the cross product is defined between the two vectors is equal to determinant IJK. Now listen, here first A vector. So A vector coefficients comes in second row. Okay, what is A vector? Here IJ, K absent. K absent means 0, which means 3, 4, 0. 3, 4, 0. Okay, next. Listen, second B vector, therefore B vector competence in third row. What is B vector? 1, 1, 1. The coefficients. Listen, 1, 1, 1. Just we know that plus, minus, plus. Okay, which is equal to plus K cap into. So K cap into. Forget its row and column. Okay, cross multiply. Very good. 4 minus 0. Okay, 4 minus 0. Next, minus into J. Minus J cap into. Forget the row and column. Anyone? Yes. 3 minus 0. Next, plus into K cap. So plus K cap into. Anyone? Yes. 3 minus 4. 3 minus 4. Now which is equal to? What is your answer? Yes. 4 I cap. Here 3. But the minus is available. So minus 3 J cap. Okay, here minus 1. So minus K cap. What is it? Which is A vector cross B vector. So A vector cross B vector is completed. But we are asked to find a modulus A cross B. Now, so listen, now modulus A vector cross B vector, which is equal to A vector cross B vector equal to 4 I cap minus 3 J cap minus K cap. But I need magnitude modulus. That means, can you tell me what is the modulus of a vector? Very good. Square root of sum of the squares of IJK. Listen, square root of, here I coefficient 4, so 4 the whole square. Plus of J coefficient 3, so minus 3 the whole square. Plus of K coefficient minus 1, so minus 1 the whole square. Now simplification yourself. Okay, start simplification. Very good. 4 square, 16, plus minus 3 the whole square equal to 9, plus 1 the whole square. Minus square gives positive, so 1. So which is equal to 10 plus 16, which is equal to root 26, which is modulus A vector cross B vector. That's all. So hence the answer. Listen, this exercise is very simple. Find the modulus A cross B where A vector and B vector is given. If the cross product is defined between the two vectors, means its answer is given by determinant IJK. First row always fixed. First A vector, therefore second row A vector coefficients. Second B vector coefficients in third row. And we know that the determinant expansion plus minus plus, and it is A cross B. And the modulus A cross B equal to square root of. That's all. 4 the whole square plus of minus 3 the whole square plus of minus 1 the whole square. After simplification, your answer will be modulus A cross B is equal to square root of root 26. And a similar sum in exercise available which is left for you as homework. Thank you.